Hello, class. Welcome back. Today, we're going to go ahead and get started with section 3.3 and 3.5. All right. These are two great sections. I love these sections. Right. Everything coming up here is awesome. Um, so right, we've noticed that finding the derivative using, in other words, what's known as the long way, right, by using the difference quotient. All right. Finding the derivative of any function, doing that, it's tedious. It takes a lot of work. There's a lot of room for error, right? But there's an easy way, all right? And we're going to go ahead and learn all these rules, and you'll see how quickly it is to find that derivative, all right? We'll see how quickly it is to find that derivative. And let me see if I can use one as an example. Let me see here. I can find the definition of the derivative of 5 over x, right? Later I'll come back to this one, right? 5 over x. All right, 5 over x. We did all of this, right? And it gave me -5 over x squared, right? So I'll go ahead and we'll go ahead and do that later. All right, but yeah, so there are different rules, right? Depending on the term that's given, the variable that's given to you, or the term, right? And we said the derivative is just the slope for that function at any given x value, right? So that means if you have a function, let's just say like f of x is equal to 3x to the 8th plus 6x to the 6th, right? You can find a blueprint for this, right? That'll give you the slope at any given point. And that's amazing. That's awesome, right? That is great to know. So what we're going to go ahead and look at today is going to be what's known as the power rule, right? And if you look, this is going to be in page 249 of your book. If you have the physical copy, that's great. If you have the digital copy, that's also great, right? We're using our book. This is going to be in page 249, right? 249. So we're going to go ahead and find the derivative, right? So if you're given a function, let's just say you're dealing with f of x to any power. It's just n, right? N is any number. How you find the derivative of this function, right? You indicate the derivative by, this is a tick, right? It's a little tick. It's not a 1, right? It's a tick. So f, right? And this is called, you could say the derivative of f, or f prime, right? You'll hear me say f prime a lot, right? So f prime is equal to, that n value is going to come to the front, and you're going to write down exactly what you have, but it's going to be n minus 1. All right. This is going to be the blueprint, all right, that we're going to be using, right, for the power rule. All right. And let's go ahead and apply that, right? Let's go ahead and apply that. Let's go ahead and do a little simple problem, all right? Let's go ahead and get our feet wet, right? So in other words, you're asked to find, your function is, let's just say x to the 3rd. You want to find the derivative of this, right? So this is going to be f prime is equal to, so generally what happens here is this 3 is going to come down, x to the 3 minus 1. So it's always going to be a power less, right? So it's always going to be minus 1. All right. And if you look at the blueprint, right, that I had, that's exactly what I have, where n is equal to 3. Meaning that the derivative for this function is 3x squared. All right. If you have, right, let's just say that you had here 3x to the 7, right? You may be asking, hey, I have a coefficient in the front. What do I do? Well, it's fine. Just bring it to the front. It's going to become buddies with that one, right? F prime of x, this is, in other words, it's going to be 7 times 3 times x raised to the 7 minus 1. So it just gets thrown to the front, which means those two are now going to multiply each other, meaning you now have 21 x to the 6th, right? That is the derivative, right? That is your derivative. Right. If I were to give you an x to the 8th and you were to see this on the outside, right? This is telling you to do something. You need to take the derivative with respect to x, meaning, in other words, this is just telling you what to do to the inside. That's telling you to take the derivative. So in other words, my derivative is going to be 8x to the 8 minus 1, right? Which is just 8x to the 7. Okay. You may be asking, well, what if I have negative numbers? All right. Yeah, you're going to have negative numbers. All right. So let's just say that you have your function is x to the negative 5. Right. Again, the same thing gets applied, but just be careful with the negative values. All right. So again, this is going to come to the front. So f prime is equal to negative 5x raised to the negative 5 minus 1. And, right, and where a lot of the error happens is here. All right, whenever you're dealing with negative numbers. Remember, that's not going to be negative 4. So it's going to be negative 5 minus 1. You're going to the left. All right, so in other words, this is going to be f prime of x is equal to negative 5 x to the negative 6. Okay. Go ahead and do a real world application, right? So let's just say that you have, this is going to be the long one we did, all right, which was what, 3.1, right? 5 over x. A skill that we need to have is learning how to rewrite fractions whenever there's a variable x. All right, so this is 5 over x. All right. Well, I know what's the power of x, right? Okay, so before I get to this, one thing I need us to remember that if you have 1 over x squared, this is the same thing as x raised to the negative 2. Generally, whenever we're dealing with these derivatives and we have variables in the bottom, we kind of don't want that. So we throw the variable up there and just remember to change the sign, all right? So meaning if you had f of x is equal to, let's just say you had 3 over x to the 10, right? This is going to be 3x to the negative 10 power, all right? And these rules are going to be, they're going to come quite handy, right? Meaning, what is the variable? What is the variable for down here? Well, if there's nothing there, we assume it's a 1, right? Meaning this is just 5 times x to the negative 1. Hey, I know how to take the derivative of that, right? I just learned the power rule, all right? So this is going to be f prime of x is equal to negative 1 times 5 x to the negative 1 minus 1, all right? F prime of x is equal to negative 5 x to the negative 2, all right? And whenever you're simplifying, you do not want negative exponents, right? So in other words, I would then throw that variable back to the bottom, right? Meaning this is just negative 5 over x squared. Look how easy that was. All right, look how easy and awesome that was, right? Look at that. Look how long it took us to do all that. That's a lot of work, right? It's not bad. It's great. You know, we're using our algebra skills, right? Putting our algebra skills to the test. But look how easy this was, right? So the thing to remember that I want us to remember is you're able to throw variables that are in the denominator to the numerator. You just have to remember to change their sign, right? And whenever you're simplifying, you want to make sure that you do not want any negative exponents. That's a no-no, right? So remember that. Another one I'm going to bring up is the square root of x is the same thing as x to the 1/2, right? The same way the cube root of x is the same thing as x to the 1/3, right? And these are rules we're supposed to know, right? Meaning 4 to the x, right? Is x to the 1/4. In other words, n, doesn't matter what you have there, n of x, this is just x to the 1/n. All right, and again, what's great about this is that you can take the derivative of squared values, all right, at square roots. So what if I had asked you, hey, I want you to take the derivative of 6 square root of x? What you're going to do is rewrite, right? You need to go ahead and rewrite. This is just 6 to the x to the 1/2. Oh, I know how to take the derivative of that. All right. This is just f prime is equal to 1 over 2 times 6 times x to the 1/2 minus 1. And again, here you want to be careful, right? Because we're subtracting fractions, all right? We're subtracting fractions. So in other words, all right, f prime of x is 6 over 2 x to the 1/2 minus 1 over 1, all right? And in order for me to combine fractions, they need to have the same denominator. So this is going to be a 2. That has to be a 2, meaning, well, 6 over 2, that gives me 3. This is x to the 1 over 2 minus 2 over 2, right? And just focusing on this fraction here, right, that is negative 1 over 2, simplified, right? So my derivative is 3x to the negative 1/2. All right, so, but what did I say before, right? I don't want negative exponents, all right? Even if it's negative 1/2, do not leave it like that. I need you all to simplify, right? Meaning I could still simplify this, right? This is just going to be 3 over x to the positive 1/2, right? I moved it from the numerator to the denominator, therefore it changes sign. And again, you don't want to leave it as 1/2, right? We don't want to leave it at 1/2 because we know what is x to the 1/2. That is just 3 over square root of x, right? So this here would be my derivative. All right, so, you know, these are going to be very, very useful in these upcoming sections, right? So let's go ahead and get started, right? I have asked to take the derivative of this function. Well, I know this is going to be 3 times 8 times x to the 8 minus 1 plus 6 times 6 times x to the 6 minus 1, right? Which is just 4x to the 7th plus 36x to the 5th. And that's it. These are derivatives, right? These are nice. These are cool. I like these. All right. Let's go ahead and do another example. All right. Let's go ahead and do, let me make one up. I'll go ahead and do a difficult one, right? One thing I also wanted to mention is what do you do when you have something like this? All right, so let's just say if I were to ask, hey, this is my function, get the derivative of this. Whenever you have x's multiplying one another, you're going to want to simplify them, right? You want to go ahead and unify them, all right? So in other words, this is, I'm going to rewrite this. This is x to the 3rd times x to the 1 over 2, all right? We know whenever we're dealing with variables and the bases are multiplying, the exponents are going to add, right? So in other words, this is just the same thing as x to the 3 plus 1 over 2. Oh, okay, right. So in other words, 3 is the same thing as 3 over 1, and it needs the same denominator as the other one, right, in my LCD. So in other words, this is x to the 6 over 2 plus 1 over 2, meaning this entire thing is just f of x is equal to x to the 7 over 2. And let me go ahead and derive that, right? The derivative of this is, it's a whole number. That's fine, right? This is just 7 over 2 times x to the 7 over 2 minus 1, right? And if you're doing always minus 1, one thing you may want to get used to doing is just seeing that instead of being 1 minus 1, remember 1 minus 1 is the same thing as 2 over 2. I'm sorry, 1 is the same thing as 1 over 1, right? And 1 over 1 or just 1, right? No, 1 is just the same thing as 2 over 2 because what is the same thing divided by the same thing? 1, right? That's the same thing as 10 over 10, right? This is just the same thing as 7 over 7. This is the same thing as 17 over 17, right? So one skill that you want to pick up is if I know I'm subtracting it by 1, and if I want to get my LCD right off the back, right, then this is just, I'm just subtracting this by 2 over 2. All right, so in other words, my derivative is just 7 over 2 x raised to the 5 over 2, right? But and with time, these would come, right? I'm going to give you a lot of these to the point that you become masters at this, right? That you're just able to solve these puzzles, all right? And of course, that's fine, right? If you want to go ahead and if you require a few more steps, right? If you want to, if you want to walk before you're able to run, that's totally fine, right? Go ahead and do the -1, find the LCD, and then you start, hopefully, right? You start seeing the bigger picture of why I was saying two. Just do 2 minus 2, right? I'm sorry, just do 2 over 2. All right. So I think I've mentioned a few of the rules, right? So let's just say I gave you another example that's like, hey, I want you to, this is what you have. I want you to take the derivative of this. All right. One thing I wanted to say is, if you're dealing with coefficients, right? If you're dealing with coefficients, right? If you're dealing with numbers that do not have x's, right? So let's just say like a 3, all right? Right, 3 doesn't have an x. So if you were to derive this with respect to x, the derivative of that is always going to be 0. Okay, I need us to remember that, right? The derivative of a constant, right? This here is my constant, is always 0. The derivative of a constant is always 0. I need us to remember that, right? The derivative of a constant is always 0. All right, let's just say I gave you another function, and this was -32. All right, it doesn't matter. It's still a constant. The derivative of a constant is 0. All right, it's always 0. If you are looking for these rules, these should be in section 3.3, theorem 3.2, the constant rule on page 247. Page 247. So in other words, I'm going to go ahead and take the derivative of this function, and I'm going to do one by one. The derivative of this is just 0. Right, but before I do that, let me go ahead and rewrite everything, right? I have fractions with variables in the bottom. I do not want that, right? This is going to be 2 plus 3 to the x minus 1 plus 2 to the x raised to the minus 2. Now I can go ahead and take the derivatives, right? Go ahead. I'm going to go ahead and just solve this one out completely. Let me know if this is what you get. Right. So in other words, the 0, right, goes away. So you should be left with -3 over x squared minus 4 over x cubed. Right. Right. There's a lot of these that you're going to just be doing right off the bat, right, that you're just going to be doing. I'm going to go ahead and give these to you. All right. If you have 1 over x, the derivative of this is -1 over x squared. The derivative of this is what? It's 2 over x cubed. The derivative of this is -6 over x to the 4th, and so forth, right? There's a pattern here going on, and as assignment, I'm going to go ahead and let you do each one of these manually, right? Go ahead and do these manually, but this is something you probably want to memorize because you're going to be doing it so much, all right? One observation you'll make is whenever you're dealing with 1 over x, and you go to the derivative, it changes sign, and then it changes again, and then it changes again, right? So that sign is going to oscillate, right? So remember that. All right. If I ask you, hey, this is your function, I want you to find f prime of 2. What you're going to do here is first take the derivative once you find the derivative of that function, right? Once you find the slope of that function, you're going to go ahead and plug that in. You're going to go ahead and plug in 2, right? So in other words, I'm going to take my derivative first. Right, this is going to be 3 times 7 times x to the 7 minus 1, which is 21 x to the 6th. All right, what I'm going to go ahead and do now, right, is plug in 2 into my derivative. So in other words, I have 21 times 2 to the 6th. wasn't expecting this value to be so large. Let's see what that gives me. Right, and while I'm computing this, and if any point you have any questions, you need an explanation, you don't understand how to find the derivative, please let me know, and I'll be more than happy to help you with these. Right, I'm here to help you succeed. All right. I get, right, I'm gonna stop talking now. 1344, right? 1344. Right, 1344 is my value. It's my slope at that point. All right. One thing I said before, right, was you can be dealing with just various letters, right? You can be dealing with, let's just say v of r is equal to 3r squared minus 7. All right, if you're gonna find the derivative, right? So this is gonna be v prime of r. This means if you're gonna anything with an r, you're going to take the derivative of, right? So it's still the same rules apply. This is gonna be 2 times 3 times r 2 minus 1. And I have a constant, -7. What's the derivative of a constant? 0, right? It's always 0. Meaning v prime of r is equal to 6r, right? That'll be my derivative. One thing I'll go ahead and mention again, I believe I mentioned it in the last video, is if you are dealing with position, in physics, generally position, it is s with respects to time, right? It's always with respects to time. So the derivative, you'll be, the variable you'd be deriving would be t, all right? Just instead of like r, the last problem we did. To take the derivative of position, this is going to give you velocity, which is vt, right? You derive velocity again, this is going to give you acceleration, right? Meaning, hey, I'll give you, for example, right? Let's apply this. If I say, hey, your position function, right? Don't let that s confuse you either, right? Sometimes we want to say, oh, s is speed. No, we just got to get used to thinking, hey, no, that is position, right? But your position function is 3t3 minus t plus 1, all right? Oh, I haven't done one with just one variable, right? I haven't done that with just one variable. Go ahead and do that one. If I ask you, hey, I need you to find s double prime, right? And that's fine. That just says you take the derivative twice, right? That's gonna ask. That's just fine. Saying, hey, this take the derivative twice. How do you take it twice? You take it one first, right? Let's find one first. S prime of t. This is going to be 3 times 3 times t3 minus 1 minus. So you might be saying, hey, well, what do I do with variables that only have one letter? Oh, one number. One at the top, I know that's a 1, and that's fine. So the 1 comes to the front, right? So this is 1 times t raised to the 1 minus 1. Let's not get scared there, right? That's just 1 minus 1, right? Plus, what's the derivative of a constant? 0. All right, so my s regular prime, this is just 9t squared minus t raised to the 0. And if you remember from the previous section, I said anything raised to the 0 power, right, is what? 1. Right, and you can go ahead and try that in your calculator. Do 100 raised to the 0. Do 6 raised to the 0, right? It's going to give you 1. Right, so in other words, s prime of t, right, is going to be 9t squared minus 1, right? And in other words, right, if you can just bear with me here, I know that the first derivative is just velocity, right? It is just 9t squared minus 1, right? Because we said if we go from position to velocity, all right, it's going to give me that, right? Meaning that if, right, let's go ahead and continue from there. If you take the second derivative to position, which is saying if that is the first derivative of velocity, this is going to give me acceleration, right? So let's go ahead and derive this. right? So this is going to be 2 times 9 times t to the 2 minus 1 minus the derivative of 1 is a constant, right? What's the derivative of a constant? That's 0, right? That's 0, meaning that my derivative is 18t. Right? And you need to go ahead and play this section back. That's totally fine, right? Don't feel overwhelmed. I'm gonna go ahead and mention this later, right? I'm gonna go ahead and I'll definitely bring this back up, right? Because I understand it's a new concept, right, for most of you. All right, so no worries. I just want to go ahead and get started with this as soon as possible, right? Constant exposure for a long periods of time would go ahead and solidify this in your brains, right? Sometimes we may have things like, what's a different example you can find, right? And everything I'm mentioning here are not homework problems, right? But these are tools that are going to help you along the way, right? Problem solving ideas, right? So whenever you have a polynomial, okay, divided by one single thing, right? When this is divided by one single thing, the great thing, because right, if I were to say, hey, derive this, we're gonna, whoa, what's going on? Or like, how do I even start? This look very different. The cool thing about this is that what you can do is whenever you have a polynomial being divided by just one thing, you can go ahead and divide everything in the top by that common denominator. So in other words, this is the same thing as 3x to the 6th over x to the 5th minus 4x to the 5th over x to the 5th plus x to the 4th over x to the 5th, right? Hey, that looks much nicer, all right? Let's go ahead and clean that up. That is, you have six variables on the top, you have 5 at the bottom, they're all cancel each other out. That means there's going to be 1 left over on the top. All right, moving on to the next part, the -4 stays, but the x to the 5th, they both cancel out, meaning that's all I have. And if we go to the last part, x to the 4th and x to the 5th, there's more at the bottom, and the difference is by 1. So that means that the only thing there's going to be is 1x at the bottom, and what goes on top. It's not 0, right? It's always going to be a 1, right, when things cancel out. Okay, let me go ahead and rewrite this one more time because I want to rewrite this fraction. Right, this is going to be 3x minus 4 plus x to the -1. At this point there, I can go ahead and take my derivative, right? The derivative of this function is going to be, and I'll let you work this one out, right? I'll go ahead and let you check your work, and you should get 3 minus 1 over x squared, all right, when you've simplified it. If you need to go ahead and pause the video, please do so, right? That is how you would solve that function. So right now, right, we've been dealing with power rules. Now we're going to be talking about what happens when things are multiplying one another. Or what can we do whenever functions are multiplying one another? All right. So let's go ahead and pull that up. All right. So for my product rule, right, it's going to be two things that contain x's, right? It's going to be two things that contain x's that are multiplying one another. So in other words, I would ask you to find, you're going to have two things that are multiplying each other, and you want to take the derivative of that, right? This is the blueprint, right? How you find this, right? This is going to be, whenever I refer to the first, I'm talking about f. And whenever I'm doing G, this is going to be me referring to the second, right? The pattern here is, give me 1 second. G, the second times the derivative of the first, plus the first times the derivative of the second. I would memorize it this way. There's a reason why. If we memorize it this way, what comes next is going to be pretty simple, right? There's going to be less room for confusion. take it from experience, right? So the bottom, G times F prime plus F times G prime. So in other words, one regular times the derivative of the other plus the other that's regular times the derivative of the other. What are you talking about, Professor, right? What are you talking about? So let's just say that we are dealing with F of t, and I have t squared plus 5t plus 1 times 3t squared minus, well, you know what? Let's do this one minus 1. Right. One thing you can say, hey, Professor, I can just go ahead and do FOIL. Like not FOIL, but distribute. That's going to take you so long, right? That's going to take us way too long. At this point, I want us to focus on, working smarter, not harder, right? Well, no, definitely always harder, right? But right, I wouldn't want you to spend like most of your time trying to distribute this, especially whenever the exam is right around the corner, literally, right? What, on Sunday? Next Sunday. So, right. So in other words, what I'm going to go ahead and locate here is going to be my left part. So this entire piece is going to be my F. This other entire piece is going to be my G, right? These are the two things that I said that are multiplying by one another. All right. One thing you may want to do is keep things organized, right? I know I need to find F, and I know I need to find F prime. I know eventually I have to find G, and then I have to find G prime, and then I can plug everything in to this wonderful formula, right? Do you have to have this memorized? You sure do. You sure do. Right? So F is going to be my first one. That is just t squared minus 5t plus 1, right? The derivative of this, right, is going to be 2t minus 5. Right? And like I said, if you need to pause the video, definitely go ahead, right? Go ahead and pause the video. The next one is G. G is just 3t squared minus 1. The derivative of this is going to be 6t. All right. At this point, hey, you have everything that you need, right? You really have everything that you need to plug in. All right. So we said we start with G. All right. We start with G. Right. I'm using this here. G is 3t squared minus 1 times F prime, which is 2t minus 5, plus F, which is t squared minus 5t plus 1 times G prime, which is 6t. This is it, right? This is it. This is F prime of t. Do not distribute. I'm not gonna ask you. I'm not gonna, ask you to go ahead and distribute all of that. You do not have to, right? So whenever you're, remember, I'm only going to grade your handwritten work, right? I'm going to grade your handwritten work. So in case your submitted homework was, right, for technical issues, it was lower. I'm always gonna grade your handwritten work, so your grade may end up being higher, right? So you may leave it like this, right? So if I were to say, hey, find F prime of t whenever t equals 7, right? Something like this. All you would do there is plug in 7, right? You would plug in 7 for every t that you have there. And at this point, yes, you would have to simplify, right? You would have to apply PEMDAS and get everything to one value. Simply plug in 7 into your t's and not simplifying, you're going to lose points for that, right? So just remember that. So that right there is known as product rule, right? That right there is known as product rule. I'm going to go ahead and do a conceptual problem, right? That I hope it helps, right? Let's just say that you're given f prime of, no, just f of x is x to the 9th times another function, right? And you're told that h whenever x equals -1 equals 4, and h prime at x equals -1 equals 7, and they want you to simplify this, all right? So, right, I'm going to go ahead and follow these rules up here, right? I'm going to go ahead and follow the rules up there. My f prime, g, my g prime, my f is just the first one, so that's gonna be x to the 9th. My g is just that h, that other one, so I'm gonna leave that right there. Right, I'm gonna go ahead and derive each one, right, and just take it step by step, right? You'll see how it all comes back, how it all comes together, right? And do not mistake in this f for that function there, all right? So f prime, right? This is going to be 9x to the 8th. H of x, right? If it's just a term like that, if it's just a variable like that, then I know the derivative is just h prime of x, right? All I'm doing is taking the derivative, therefore just writing the tick, right? I'm going to go ahead and plug this into the formula, right? I should get g times f prime, which is 9x to the 8th, plus f, which is x to the 9th, times g prime, which is h prime of x. And that would be it, all right? This here would have been it, right, if that's all I had asked. But I need you to compute this f prime whenever x equals -1. So what I'm going to do is wherever I see an x, I'm going to go ahead and plug in a -1. Right. The first one, h of -1, right? This information here was given. All we need to do is go ahead and make substitutions. H of -1, that is just 4, times 9 times -1 raised to an even power. What did we say about that, right? -1 raised to an even power, that is just going to be positive, right? +1 plus, we have -1 raised to an odd power, right? That's going to be negative, times h prime of -1. Well, that's given here. In other words, that's just going to be 7, right? Let me go ahead and simplify there. 4 times 9, this gives me, right, this gives me 36 minus 7, right, which is just 29. Right, so my final answer here, right, my final answer there would just be 29. Right, so please do a lot of these, right? This here is known as the product, the product rule, right? Whenever your terms are multiplying. And of course, just like whenever they're multiplying, they're going to be what? They're going to be dividing, all right? So you want to know what is the derivative whenever two things are multiplying, all right? Whenever they're dividing, all right? So this is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. All right, and if you notice, this top part is almost similar, if not exact, to the product rule, with the exception that there's a minus there, right? So that's why I said if you learn how to do the other one for the quotient rule, you know that the only different thing would be that there's a negative there, and with the quotient rule, you're dividing it by g squared, right? Let's go ahead and do one of these, of course, right? Let's go ahead and do one of them. All right, so let's just say that I ask you find, this is your function. I'm just going to call it m. Your function is going to be, give me 1 second here. Okay, I'm back. I'm sorry about that. So we want to go, I'm going to go ahead and give you this function. This function is going to be, we'll say 5x plus 3 over 2x minus 1, right? So the first thing I'm going to go ahead and do is locate my f. I know my f is my top part, which is 5, 3. I know I have to eventually find an f prime. My g is going to be 2x minus 1, and I know eventually have to find a g prime. All right, we know whenever we're taking the derivative of a term that just that is to the 1 power, right, it's just going to be the coefficient in front of it. So this is just 5. All right, if you want to go ahead and show your work to write it by hand, you'll see that as well. All right, and the same thing for this part. All right. it's going to be 2. All right, so I'm going to go ahead and follow these rules. It is the bottom, all right, which is going to be E. Let's go ahead and see here. The bottom, right, bottom, which is G, 2x minus 1, times f prime, which is 5, minus the top, derivative of the bottom, right, all over the bottom squared, right? So my bottom is G, so this is all over 2x minus 1 squared. Whenever you're doing quotient rule, you need to simplify the numerator, but do not simplify the denominator. I would say like 99% of the time, you do not have to go ahead and simplify the denominator. And as you continue with the course, you'll eventually find out why, right? Why it's very nice algebraically to not solve for the denominator, to not simplify the denominator. So the top, right, I'm going to go ahead and simplify by distributing this 5 into there. Well, you know what? Let me go ahead and rewrite this, all right, so we can see it. In other words, this is 5 times 2x minus 1 minus 2, 5x plus 3, all over 2x minus 1 squared. Right, so simplify, right, what I'm going to go ahead and do to the numerator is distribute this in there and then these into there. All right, so this gives me 10x minus 5 minus 10x minus 6, right, all over 2x minus 1 squared. On the top, whenever I simplify, right, it's going to give me negative 11 over 2x minus 1 squared. Ta-da! That here's your denominator, your derivative, right? So that is how you go ahead and apply the quotient rule, right? The quotient rule. Right? And of course, there are different ways you can solve these problems, right? There are different ways you can solve these problems. So let's just say that I gave you 6 x squared plus 7x plus 2, all of this divided by the square root of x. All right, there, I know you can rewrite this, right? So let's just say this is L of x. I'm going to go ahead and rewrite this because I do not want the square roots, right? I know that's just raised to the 1/2. So this is 6x squared plus 7x plus 2 all over x to the 1/2. There are 2 things you can do here, all right? There are 2 things you can do here. You can apply the quotient rule, right, which is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared, or you can go ahead and write this out as, right, you can go ahead and split this like this, like we mentioned earlier. And then, right, you simplify your x's, then move into the numerator to apply the power rule, right? It's up to you, whichever way you want to solve it, right? That's the beautiful thing about calculus, right? That there's many different ways you can go ahead and solve something, and unless I specify, right? Hey, apply the quotient rule here, right? If I just say, hey, this is L of x, find L prime of x, and there's no specific instructions, you can do whichever method you want, right? You can go ahead and do any other method you want. So for this problem, you can go ahead and do that. You can go ahead and do, right, you can do quotient rule. You can go ahead and split it up into apply the power rule individually. You can even apply the product rule, right? How? I'm going to move this entire piece to the top, right? So then this is just 6x squared plus 7x plus 2 times x to the negative 1/2, where this is now your f, and this is your g. You can apply product rule if you like, all right? It's completely up to you. Whenever I grade your work, I would have said any of these 3 methods, right? Unless I specifically specify, hey, use product rule, or hey, use quotient rule, all right? But whichever method you prefer, right? But I will say, right, these are all individual skills, right? These are individual skills. If you're lacking experience on one, then right, I would definitely solve it using that method, right? Because I can assure you for the exam, I'm going to keep things, I would try to keep things balanced, right? Where you're going to get a good amount of these, a really good amount of these, and a really good amount of these, right? Um, all right, so not only will I be giving you the choice to solve it your method, but I'm going to be specific in right, in which method I want you to solve it as. All right. So this here was quotient rule, right? Um, that there was go ahead and quotient rule, right? Um, we're going to go ahead and move in towards taking the derivatives of trigonometric functions. Specifically, right, to start off with, we're going to be looking at sine and cosine, right? To take the derivative of sine, all right, it's going to be cosine, but it's going to be the same. It's going to be the same sign, all right, and the same sign as SIGN, right? One thing that I want you to remember now, if you're watching this, is get this. If you're taking the derivatives of trig functions that start with a letter C, associate that with change. That's going to determine what's going to happen to the sign SIGN when you take the derivative, right? Meaning that the derivative of this, all right, it's going to oscillate back to sine. So in other words, sine and cosine are going to flip-flop back and forth, but it's going to change SIGN now. It's going to say change sign. Remember, it's only when you derive a trig function that starts with the letter C, C stands for changed, are you going to change the sign? If you keep deriving this, right, it's going to be negative cosine of x. If you derive negative cosine, I'm deriving a trig function that starts with a C. It means it's going to change sign. So in other words, this is then going to be a sine of x. If you notice, I'm back to where I started. Right, so practice with these, because I'm definitely going to give you something like this, right? I'm definitely going to go ahead and give you something like this. All right, so just to remember, the derivative of cosine, right, would be negative sine of x. The derivative of negative sine of x is negative cosine of x. The derivative of negative cosine of x is, it's C, it changes, so it's going to be sine of x. The derivative of sine of x is just cosine of x. And I'm back to where I started, right? So definitely practice with these. Right, I wrote something off here a little bit earlier that I wanted us to just remember. These are all algebraic stuff that I wanted us to remember. We said 5 roots of x is just x to the 1 over 5, right? You may be wondering, hey, what happens if I'm dealing with x to the third? Well, this is just going to be x to the 3 over 5, where the top number is your exponent, right? Well, they're both exponent, right? But this one here is the degree of root, right? So in other words, if you had 7 root x to the 12, right? This is x to the 12 over 7, right? And so forth. So just remember that, right? It's going to come very handy. I may ask you, right? Hey, I want you to find the derivative of x to the third times cosine of x. Whoa, what do I do there? Well, we apply everything we've learned, right? We'll go ahead and apply everything we've learned here. How you do this is, remember, these are two terms that are they're terms with respect to x that are multiplying, right? If they're multiplying, that is going to be product rule, right? Product rule is right. This product rule, derivative for things that are multiplying, meaning my f is going to be my x cubed, my f prime is going to be something, my g is going to be cosine of x, and my g prime is going to be something, right? So deriving x to the third, this is 3x squared, and deriving cosine of x, this is negative sine of x, right? Meaning whenever I plug this in all together, right, to find the derivative of this function, right, this is going to be cosine of x times 3x squared plus x cubed times negative sine of x, right? And I want us to clean things up, right? Generally, you want coefficients whenever you're dealing with terms like this and like that. You want the sign in the very beginning, in the very front to the left. You then want coefficients, all right, like numbers. You then want variables like x to the something, and then at the end you want things with like trig functions, all right? So your answer should look like 3x squared cosine of x minus x cubed sine of x. Very pretty, right? A beautiful derivative. That is that right there. All right. And again, right, I may throw some mixes in there, all right? You may have to find the derivative of something like this, right? Hey, this is z of x. Find the derivative of this, right? You're going to have to apply everything that we know, right? You're going to have to apply everything that we know. So please save all your notes, right? Please save all your notes. If I ask you to find you are dealing with sine squared of x, and I want you to take the derivative of that, I need us to remember, what did I say in the previous sections, right? This is just sine of x to the second power, meaning I just have two of these. Right? That's all it means. Meaning, hey, there are two things that are multiplying, right? So in other words, this is going to be my f, this is going to be my g. I'm going to go ahead and apply product rule, all right? I'm going to go ahead and apply product rule, all right? So right, there's going to be a lot of product rule things here, all right? You won't really see this one, all right? This next one I'm going to go ahead and mention. You're really not going to see it, but in case it comes up, right, in life, right? You're shopping and somebody, right? You're shopping for groceries and somebody wants to know, hey, real quick, help me. How do you find the derivative of this? Hey, at least you'll know, right? You have, let's call this the h function, all right? You are asked to find the derivative of three things that are multiplying each other, all right? Three things that are multiplying each other, where, in other words, this is going to be my f, that's going to be my g, and to add another letter, I'll say that's my h, all right? And this here was n, all right? So to find the derivative of this, right, to find the derivative of three things that are multiplying each other, right, this is going to be the derivative of the first times g times h plus the derivative of the second times g plus f times g times the derivative of the last one, right? So you see that pattern going on, right? You multiply them all together, but just that you right, the derivatives are switching between them, right? So f is 3x, meaning f prime equals 3. G equals cosine x, meaning g prime is negative sine of x. H is equal to sine of x, meaning h prime is equal to cosine of x. You plug and you polish things up like we did on the previous problem, right? Where you want your coefficients first, then your variables, and then the trig functions at the end with the sign SIGN in the front, right? So that's how you would go ahead and approach those. Right. You may see these trig functions, right? Like I said, you may go ahead and see these trig functions. You may see something like, I'm running out of letters here. Let's say P. P of x is equal to 8x over, you may have 2/3 in the denominator, right? Sine of x plus cosine of x. Do not make this. Do not say, hey, what the professor said was I can use this. No. You can only do the split if you have a polynomial or you have more than one thing on the top and only one thing at the bottom, right? So this does not equal this. Later in class, we may touch up on that, right? If it's not calculus 1, I believe it's actually calculus 2. So if you're taking those, get ready for something like this, right? But in the meantime, no. All right. So in other words, what you're going to do here is, hey, this is quotient rule. Two things are multiplying, all right? Where f is my top, all right, which is 8x. I'm going to find an f prime. And then I have g, right, which is sine of x plus cosine of x. And that's fine. In your g, in your denominator, you may have more than one term, and that's completely fine. And g prime, we'll find out. So the derivative of 8x is going to be 8, right? Because we said whenever you just have one term of degree 1, it's just the coefficient in front of it. And whenever you're deriving g, you'll find out that this is cosine of x minus sine of x. And you would plug everything in to the derivative function. Right. To find the derivative of px, all right, meaning this is going to be something like x plus cosine of x times f prime, which is times 8. I'm going to go ahead and solve these with you guys. Times 8x times g prime, which is cosine of x all over the bottom squared, which is just sine of x plus cosine of x squared, right? Cleaning up the top, right? I'm going to go ahead and distribute this into there, then this to here, this into here, right? This should give me 8 sine of x plus 8 cosine of x minus 8x cosine of x minus 8x sine of x all over, let's see what I have here, all over sine of x plus cosine of x squared, all right? Squared. Yes. All right. There's a lot of things you can do here, right? You can simplify this even further, but right, you would leave it like this. If for some reason I were to say, hey, I want you to find f prime for x equals pi, right? That means for every x, you're going to have to go ahead and plug in pi, and then we need to go ahead and remember our trig identities, right? Well, what is sine at pi? What is cosine of what is cosine at pi? Right. So in other words, this here would be 8 sine of pi plus 8 cosine of pi minus 8 pi times cosine of pi minus 8 pi sine of pi all over sine of pi plus cosine of pi squared, right? And one thing we remember is pi is 180 degrees, meaning this point is negative 1, 0, which this belongs, I know this is terms of x and y, and x represents my cosine with y, right, representing my sine. All right, so you might need to go ahead and clean this up. Let's go ahead and do that here. Sine at pi, that's going to be 0. So this is 8 times 0 plus 8 times cosine of pi, that's negative 1, minus 8 pi cosine of pi, that is negative 1, minus 8 pi sine of pi, that's 0, all over sine of pi, that's 0 minus 1 plus negative 1 squared. Whew, right? Meaning the top, I get 0 minus 8 plus 8 pi minus 0 all over 1, meaning my answer would just be negative 8 plus 8 pi, or 8 pi minus 8, right? The order of those wouldn't matter. But yeah, that'll be something I would expect us to know, right? That looks so nice. I'm gonna leave that there, right? It hurts to erase it. One thing I want us to remember is if you have your trig, all right, where are they at? Our trig formulas, All right. Oh, I need to go ahead and send you all a cheat sheet with the derivative list. I'll go ahead and send that out in a bit. One thing I needed us to remember, I was going to send you, oh, there we go. I need to go ahead and send you all this sheet as well. Are my reciprocal identities, right? That sine of x is 1 over cosecant of x, right? Cosecant of x, therefore being 1 over sine of x, right? Cosine of x equaling 1 over of x, therefore secant of x is equal to 1 over cosine of x, right? We're missing tangent of x equals 1 over cotangent of x. Cotangent of x equals 1 over tangent of x. Two more things to remember. That tangent of x is just sine x over cosine of x, right? And that cotangent, right? Cotangent of x. This is just cosine of x over sine of x. So this shouldn't be new. If anything, make sure you refresh this. If you need any assistance with that, or you would want extra assignments or something, please let me know, and I'll be more than happy to assist you with that. Which leads me to this next question, last and final question. If I ask you, hey, I want you to find me the derivative of this. Right. You may be saying, hey, do I need to apply product rule or quotient rule? So one thing I would probably do, because at this point, we do not know the derivative of tangent, right? We are eventually going to know it later, right, in the next section. But for right now, we don't. So one thing I just need us to do here is I would go ahead and rewrite everything in terms of sine and cosine. All right. So what I'm doing here is splitting things up. And it's going to be a very great skill to have. Because in other words, if technically I have two things divided by one thing here, two terms divided by one thing, or actually three terms, right? 3 times x squared times tangent of x divided by one thing. But remember, we know that division is the same thing as just multiplying, right? What I have here is 1 over secant of x times 3 times x squared times tangent of x. That's technically what I have, right? And I would highly advise that we get used to seeing things like this, right? Like just not condensing things, but uncondensing them, right? Just separate them far enough, for you to see what's the big picture going on here, right? And I think I was on P, so now I'm going to go ahead and Q, right? If I ask you to take the derivative of this, and we know with a lot of these, right, we need to rewrite certain things. I know what's 1 over secant. It's reciprocal. It's not S. It's not the original 3 with S. It has to be with C. So therefore, it has to be, this is just cosine of x times 3 times x squared times tangent is just sine of x over cosine of x, right? Hey, these two cancel out, meaning all I have here is 3 times x squared times sine of x, right? Generally, right, whenever you're applying the product rule and you have, let's say, like the x squared, you want to go ahead and bring any coefficients with it, right? So in other words, your f would be 3x squared, and your g would be sine of x. And at this point, you can go ahead and do your product rule. All right, you can go ahead and do your product rule. So that is all I have for today. All right, this is all I have for today. This is a very important section. All right, I would say the first few sections were very important, but everything leading up forward is heavily based on these three. All right, these are great. This is a great section, 3.3 and 3.5. So be sure you fully understand these moving forward. And like I said, I'm going to be available through different methods, as I've mentioned in the syllabus, all right, and in the start here. So please be sure that you ask. If you need any help, I don't know if you need help unless you ask me, all right? Unless you send me out a message or something. So remember, I'm here, I am available. Just let me know. And thank you very much for your time, and I hope you enjoy the rest of your day. Thank you.